8051 output interfacing. The C8051F226 microcontroller is a typical 8051. These are the I/O pins. Let's rearrange and simplify the representations of the pin configuration. This set of I/O pins is called port 1. This is port 0. This is port 3. This is port 2. A typical 8051 has 4 I/O ports and a total of 32 I/Os. This is a representation of the special function registers. Port 0 is mapped to a register by the same name. So are the other ports. All the bits in these registers are bit addressable. These are the bit addresses of the bits in register P0. These are the names of the individual bits. If this is the data inside register P0, a similar signal appears at the physical I/O pin. This is bit P0.7. It corresponds to the signal at I/O pin P0.7. To get this signal at port 0, simply move immediate data 36 hex to P0. The binary of 36 hex is 00110101. How to make this I/O output a logic 1? Simply execute the instruction set bit P1.5. To output a 0 at this I/O, use the clear bit instruction. A LED can be connected to the I/O pin in this manner. This is the anode of the LED. This is the cathode of the LED. A logic 1 at the anode and 0 at the cathode forward bias the LED. The LED turns on. This point is at logic 1 because it is connected to the VCC through a resistor. The logic at this point is determined by the signal that is outputted at P1.0. The set bit P1.0 instruction sets P1.0 to 1. The LED turns off. The clear bit P1.0 instructions clear P1.0 to 0. The LED turns on. The I/O pins have a current limitation. The LED are normally not connected directly to the I/O pins. They are usually connected through a buffer IC. One example of a buffer IC is a ULN2803. This is an inverting buffer. The signal that goes in is inverted at output. A 0 will be inverted to 1. 1 will be inverted to 0. A 1 at this I/O pin will cause the LED to turn on. A 0 will turn off the LED. How to write a program to make the LED blinks? First, turn on the LED with a set bit P1.0. Then turn it off with a clear P1.0 instruction. Repeat the instructions. Is there a problem with this simple program? 8051 instructions typically take microsecond or less to execute. This program will make the LED blinks at microsecond rate. To slow down the blinking rate, insert delays here. Let's do a subroutine call. D1 is a subroutine that executes in a loop for a certain period of time. This instruction will turn on the LED. The program jumps to the D1 subroutine. The program returns. This instruction turns off the LED. The program jumps to the D1 subroutine again. The program returns. The sjump M1 causes the program to run in an infinite loop and causes the LED to blink at a rate determined by the D1 subroutine.